Now in this chapter, we'll be looking at elements and compounds. We'll be learning on what are elements, how are they classified in the periodic table, what are compounds and mixture, by comparing and contrasting the differences between your compounds and mixture, as well as how to interpret chemical formulas of compounds, and last but not least, what are molecules. Now, we know that all matter is made out of elements. For example, the human body is made out of oxygen, hydrogen, carbon, calcium, phosphorus, nitrogen, as well as other elements. Okay, another example, the Earth's crust is made out of your different elements. They are listed over here. Now, what exactly then is an element? We classify an element as a substance that cannot be broken down into simpler substances by physical or chemical methods. All the substances are made out of elements. For example, water is made out of two elements, namely hydrogen and oxygen. Each element has a name and a chemical symbol. Every symbol has one or two letters only. For example, the element hydrogen has a chemical symbol H. Oxygen has the chemical symbol O. Aluminium, on the other hand, has a chemical symbol Al. And iron has a chemical symbol Fe. Do take note, when an element has a chemical symbol with two letters, the second letter must be written in small letter. Test yourself. Pause the video now and write down the chemical symbol for the following elements in your notes. Continue the video once you have completed the exercise. Classification of elements. Elements can be classified in three different ways: their physical state at room temperature, whether they are metals or non-metals, and their properties. First of all, let us look at classifying elements based on their physical state at room temperature. On the slide itself, you see some example of metals as well as non-metal. Let us look at the metals first. Now we have the element mercury, which is a liquid at your room temperature. Okay, when talking about room temperature, we are talking about 25 degrees Celsius. Okay, at 25 degrees Celsius, your mercury will exist in the liquid state. And for gold, your gold will exist in the solid state, and for lead will exist in the solid state as well. Now, let us look over on the right part of the table and look at the non-metal elements. Your chlorine will exist as a gas at room temperature, bromine as a liquid at room temperature, and your sulfur as a solid at room temperature. Next, we can also classify elements based on whether they are metals or non-metals. Elements are classified as metals and non-metals depending on how well they conduct electricity. If you look at the periodic table, you have noticed that most of the elements are metals. There are only 22 elements which are non-metals. Now, this is an example of your periodic table. On the left hand side of the stairway line, you have the metals, on the right hand side, you find the non-metals. Except of course in this table the hydrogen is a non-metal, but it is actually located on the left hand side of the periodic table. Now what are some of the properties of your metals and non-metals? When we talk about metals and non-metal, we need to examine some of the properties. For metals, we are talking about metals being good conductors of heat and electricity. They have high melting and boiling point. However, Group 1 metals and mercury has very low melting and boiling point. That is why your mercury is actually a liquid at room temperature. Okay, your metals are also malleable and ductile. They have high density, again except Group 1 metals, and they have shiny appearances. Your non-metals, on the other hand, they are non-conductors of heat and electricity. They have very low melting and boiling points. They are brittle and break easily. They have low density, and they look dull in their appearance. Now, under the properties of metals, you may want to find out what does malleable and ductile means, and we'll discuss this further in class. Some elements, on the other hand, they are classified as metalloids, which have both properties of metals and non-metals. Some examples are silicon as well as boron. Your elements are arranged in periodic table according to their properties. Element in each row or the period shows a gradual change from metallic to non-metallic properties when moving from the left to the right across the periodic table. Elements in each column or the group are arranged according to similar chemical properties. When we're talking about particles present in elements, we are looking at atoms as well as molecules. Then what exactly is an atom? An atom is the smallest particle of an element that has the chemical properties of that element. It has a diameter of about 1 × 10⁻⁻9 meters, and it cannot be observed with a naked eye, but can be seen using an electron microscope. Each element consists of a particular type of atoms. For example, a gold ring is made up of gold atoms only, and each atom has a symbol. This symbol is the same as the symbol for the elements. Now in this table you see some of the elements as well as some of the symbol for the atom. What then is a molecule? Now a molecule is made up of 2 or more atoms chemically combined together. Molecules of elements consist of a fixed number of one kind of atoms only. Okay, please take note. Your molecules of elements consist of only a fixed number of one kind of atoms. For example, a molecule of chlorine gas is made up of 2 chlorine atoms chemically combined together. That's why your chlorine gas has the chemical symbol Cl2. Now these are some other examples of molecules of elements. You have your oxygen, chlorine, bromine, phosphorus, as well as sulfur. Let us look at compounds. A compound is a substance containing two or more elements joined together by chemical bonds. A chemical reaction occurs when a compound is formed from its element. For example, magnesium oxide is made when magnesium is burned in oxygen. This is the word equation for the reaction above. You have your magnesium reacting with your oxygen gas to produce your magnesium oxide, which is a compound. The chemical equation is provided above. Your magnesium burns with a bright white light, and a lot of heat is produced in this reaction. In this second example, your water is formed by applying a lighted splint to a mixture of hydrogen and oxygen gases. The word equation is provided below. This is the chemical equation for the reaction between your hydrogen and oxygen to form your water. Now, when you're talking about compounds, the particles present in a compound can be a molecule or can be ions. Molecules of compounds consist of a fixed number of two or more different kinds of atoms chemically combined together. The key word over here is two or more different kinds of atoms chemically combined together. For example, a molecule of water is made up of two hydrogen atoms and one oxygen atoms chemically combined together. Okay, this ratio of two hydrogen atoms and one oxygen atom is fixed for all molecules of water. Now, these are some other examples of your molecules of a compound. You have your water, which is made up of your hydrogen as well as your oxygen element, and your carbon dioxide made up of your carbon and oxygen, methane, which is made up of your carbon and hydrogen. Diatomic molecules are those that contain only two atoms. Some examples are your carbon monoxide, CO, hydrogen, H2, nitrogen gas, N2, and iron oxide, FeO. Polyatomic molecules, then, as the word polyatomic suggests, are those that contain three or more atoms. Some examples are your carbon dioxide gas, your sulfuric acid, your nitrogen dioxide, so on and so forth. Molecules can be represented using chemical formula. As you all know, the chemical formula for water is H2O. The chemical formula of a molecule shows the elements present as well as the number of atoms of each element that is present in the substance. If we look at chlorine gas, the chemical symbol for chlorine gas is Cl2. This is the chemical symbol of the element, and the subscript actually shows us the number of atoms present in one molecule of chlorine gas. Now in this example, we have your nitric acid, HNO3. Notice that there is no subscript on hydrogen atom. In such cases, we assume that there is only one hydrogen atom. If you look at the oxygen, the subscript showing 3 oxygen atoms are present in this molecule. Next, we have your magnesium hydroxide, MgOH2. Now the subscript 2 means that we have to multiply the number of oxygen atoms and hydrogen atoms inside the bracket. This means that there will be a total number of 2 oxygen atoms as well as 2 hydrogen atoms present in your magnesium hydroxide. There are 2 types of formula. The first type is what we call the molecular formula. The molecular formula of a compound shows the total number of atoms present in one molecule. The second type is the empirical formula of a compound. And the empirical formula of a compound shows the simplest ratio of atoms of each element present in the molecule. Test yourself. Now if you look at your handout, the chemical formula of 6 compounds are given below. Name the elements in the compound and state the ratio of the atoms in the compounds given. You can pause the video now to answer the questions. Let us move on. The last section on this chapter, we are going to be looking at mixtures. Exactly what are mixtures? A mixture consists of 2 or more substances which are mixed together but not joined together by chemical bonds. Elements and compounds can be mixed together to form a mixture. Now, below shows some arrangement of particles in a mixture. In the first box, we have a mixture of 2 elements. Okay, let me call this element A and element B. Now, if you look at element A, you will notice the element A is actually a molecule of an element, whereas your element B is an atom of the element. Now, in the second box, we have a mixture of 2 compounds. Namely, I'll call this your compound A. Okay, the gray color compound over here, and your compound B, the blue color compound over here. If you look closely, your compound A consists of 3 atoms chemically combined together, and your compound B consists of 2 atoms chemically combined together. Last but not least, in the third box, we have a mixture of 1 element and 1 compound. Of course, in this case, the element must be the blue particles over here. This is the element, the molecule of the element, and your gray color compound over here. A mixture does not have a fixed composition. This is unlike your compound. The percentage of each element in a mixture is always not the same. Now, let's look at the compounds and mixtures and compare some of the properties of your compound and mixtures. First of all, let us look at the physical or chemical change between a compound and a mixture. For a compound, a chemical change takes place when a compound is formed. whereas for a mixture there is no chemical change that is taking place when a mixture is formed. Like what we have mentioned just now, your compound has a fixed composition by mass, whereas your mixture has variable composition by mass. Next, we look at the boiling and boiling point of your compound and mixture. For a compound, it will have a fixed melting and boiling point. Compare this with your mixture. Again, your mixture will have a variable melting and boiling point, and it melts and boils over a range of temperatures. Properties. A compound has unique properties, both physical and chemical. Whereas for your mixture, it will have the same properties as its component, meaning the different types of things that you add in the mixture, it will have the mixture will have the same properties as those. Separation. Your compound cannot be easily separated by physical means, whereas a mixture can be separated by physical means. Last but not least is the arrangement of the atoms in a compound and in a mixture. We have come to the end of this topic.